Hello Dicers, my dream chasers. Welcome back to Dice Decides. So I made a community post asking you guys if you are interested in something called Tech Tuesdays, where I would talk about new inventions humanity has come up with. So you guys seem really excited about that, so I am a man of my word, and here is me making a Tech Tuesday. So here we go. Today we're gonna talk about the smallest remote-controlled walking robot ever. Smaller than a flea. Okay, so when I saw this article, it blew my mind because here's a picture of it. Magnified view of the tiny crab robot standing on the edge of a coin. It is so tiny and it's remote controlled. Guys, this is intense. It's insane to see how far they've come. So, what does it say in the article? The smallest ever remote-controlled walking robot has been created by Northwestern University engineers, and it takes the shape of a tiny, cute, peaky-toe crab. Mechanical crabs are taking over, guys. The tiny crabs, which are about 1/2 millimeter wide. 1/2 millimeter. That is tiny indeed. That's like very tiny. Can bend, twist, crawl, walk, turn, and even leap. Additionally, the scientists created millimeter-sized robots that resemble inchworms, crickets, and beetles. Oh boy. The study is experimental at this time, but the researchers think their technique might move the field closer to developing tiny robots that can carry out useful tasks in small, cramped areas. The study was recently published in the journal Science Robotics. The same team also unveiled a winged microprocessor in September of last year. It was the tiniest flying object ever created by humans. Oh my god, that sounds exciting too. See, there's a lot of new tech coming out these days, so I think this would be a fun series to talk about just new tech out there. Some epic tech. This is so exciting. Robotics is an exciting field. What? Don't copy me, I just said exciting. Of research, and the development of microscale robots is a fun topic for academic exploration. Very fun indeed. This is exciting to look into, said John A. Rogers, who led the experimental work. You might imagine micro-robots as agents to repair or assemble small structures or machines in industry, or as surgical assistants to clear clogged arteries, to stop internal bleeding, or to eliminate cancerous tumors, all in minimally invasive procedures. Here's another picture of them. They can make a whole army of crabs now. Smaller than fleas, several miniature crab robots stand together. I mean, even fleas are small, so oh my gosh. Our technology enables a variety of controlled motion modalities and can walk with an average speed of 1/2 its body length per second. 1/2 its body length per second. Okay, that's pretty slow, added Yonggang Wang, who led the theoretical work. This is very challenging to achieve at such small scales for terrestrial robots. Yeah, I can imagine. But it's insane that they move at all to me. That they can be controlled. Oh man, that's so cool. Huang serves as a key member of blah 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 blah. Okay, the crab, which is smaller than a flea, is not propelled by sophisticated machinery, hydraulics, or electricity. Instead, the elastic resilience of its body is where its power rests. The elastic resilience, okay. The researchers employed a shape memory alloy material to build the robot, which transforms to its remembered shape when heated. What? This sounds complex. In this case, the scientists heated the robot quickly at several targeted spots all over its body using a scanned laser beam. Upon cooling, a thin layer of glass will elastically restore the distorted shape of the corresponding component of the structure. Interesting. As the robot changes from one phase to another, deformed to remembered shape and back again, it creates locomotion. Not only does the laser remotely control the robot to activate it, the laser scanning direction also determines the robot's walking direction. Scanning from left to right, for example, causes the robot to move from right to left. Because the structures are so tiny, the rate of cooling is very fast, Rogers explained. In fact, reducing the sizes of these robots allows them to run faster. What? To manufacture such a tiny critter, Rogers and Huang turned to a technique they introduced 8 years ago, a pop-up assembly method inspired by a child's pop-up book. First, the team fabricated precursors to the walking crab structures in flat, planar geometrics. Then they bonded these precursors onto a slightly stretched rubber substrate. When the stretched substrate is relaxed, a controlled buckling process occurs that causes the crab to pop up into precisely defined three-dimensional forms. With this manufacturing method, the Northwestern team could develop robots of various shapes and sizes. So why a peaky toe crab? We can thank Rogers and Huang students for that. With these assembly techniques and materials concepts, we can build walking robots with almost any size or 3D shapes, Rogers said, but the students felt inspired and amused by the sideways crawling motions of tiny crabs. It was a creative whim. Okay. Okay, well, thoughts. Yeah, it's amazing that technology has come this far. I'm excited to see what other new tech is out there. I think it's gonna be, more and more exciting new tech coming out the coming days or years at least. So yeah, I'm definitely excited because I can find new tech every week, I'm pretty sure. So I want to make this a series. Tech Tuesdays. Who's with me? Let's do this. Okay, it's exciting, right? Okay, well, that's it for this episode, so remember to gently tap on that like button and ring that bell so you don't miss an upload. And thanks for watching, Dicers. Hope you have a fantastic rest of your day, and I will see you next time.